Alright, this is a video showing you how to collect some data about distance and force in this PhET simulation about charges and fields. I'm going to start by clicking on this grid showing specific values, and I can immediately tell that each of these boxes, each of these small boxes is worth about 10 centimeters, and that means that 10 of the boxes, or 2 of the larger boxes that you can see, is exactly equal to 1 meter. When I place this positive charge, you'll notice that I've affected the space around the charge somehow. What these arrows are showing is electric field, and if we place a sensor somewhere in this electric field, this will show us the strength of the force that this sensor would feel if it had a charge, or it's showing us in fact the strength of the field at that spot. Now, if what we're interested in is force, we need to think about how we can connect this electric field to force, and I can show you that here. Units of volts per meter that are given here are equal to units of newtons per coulomb. We don't need to go into the reason for why these units are equal, but we can tell that a unit of field is giving us a unit of force per unit of charge in this case. So if we're dealing with a force field, we'll always see units of newtons per something that either has charge or mass, like newtons per coulomb or newtons per kilogram in the case of gravitational field. So if we want to think about each of these numbers as a force, we need to assume that each sensor has a charge of 1 coulomb and say, okay, what will that charge of 1 coulomb be experiencing? Moving on, we can place a bunch of these sensors out wherever we want. This one is really close. It's 50 centimeters away or 0.5 meters away. You can tell that electric field or that force is extremely high. If I place one, I'm just going to move this out to 1 meter so that the arrow isn't as long. And then I can place another one at 2 meters, another one at 3 meters away from here, and so on and so forth. Notice I'm being really careful to lay my sensors on this one axis, so I only have to worry about distance as measured by this tape measure. If I was to move my value or move my sensor over here, I would have to be careful to measure the distance with the tape measure along that diagonal, which is not as convenient to do, so I'm going to just put the tape measure away and keep my sensors on this one axis of distance. So you notice I'm already able to find a relationship, if I was to graph this and analyze it, between distance of the sensor from the charged particle and the force that that charged particle would be experiencing. Again, technically, if we're thinking about the units, if I want to interpret this number 9.2 as 9.2 newtons, a unit of force, I would need to assume that this sensor has a charge of 1 coulomb and go from there. So we're able to use the distance of each sensor and the field at that place, or the force at that that sensor would experience, to investigate the relationship between distance and force, or the effect that distance has on the force that each of these sensors experiences.